I'm going over the Chapter 4 practice test so you can understand how to do these problems. For number 1, you're just taking the cube root of negative 125, which is negative 5. It's pretty straightforward. For number 2, you're taking the cube root of negative 64 and then squaring that. So the cube root of negative 64 is negative 4, and you're going to square that, so you're going to get positive 16. For number 3, you're going to reduce 12 into 96 first. That will give you the cube root of 8, which is 2. If you rather go into primes and reduce that, that'll work as well. For number 4, you're going to add the two exponents. So 5/3 is 10/6 plus 1/6 to the negative 6. So when you add that, you get 10 to the, you get 3 to the 11/6 times negative 6, which is 3 to the negative 11, which is equal to 1 over 3 to the 11th, which is 1 over whatever 3 to the 11th is, which is 3. Let me put that on my calculator. 11 is 177,147. Make sure your fraction bar is long enough to cover all those numbers. For number 5, we're going to put everything into primes, or at least into multiples of 3. So 54 is 27 times 2. Then the exponents, I'm going to make those divisible by 3, so x to the 6th, y to the 3rd times y squared, z to the 9th times z squared. Then you can circle groups of 3, which are perfect cube roots. So the 3 will come out of the radical. We're going to have an x squared come out of the radical. Also, we're going to have a y and a z to the 3rd. And then in the radical, you're going to have a 2y squared, z squared. And that is a cube root, so don't forget the 3 there as well. For number 6, I'm going to distribute this negative 1/3 to everything. That's going to give me y to the negative 2/3. It's going to give me 27 to the negative 1/3. And then negative 1/3 times negative 6 is x squared. When I rewrite this, x squared stays where it is because it has a positive exponent. The y moves to the denominator and becomes positive 2/3. And then 27 to the 1/3 moves up and becomes positive 1/3. 27 to the 1/3 in the numerator is 3 because that means the cube root of 27. And the denominator just stays exactly how it is, x squared, y to the 2/3. Make sure that looks like a exponent. For number 7, whenever you're adding or subtracting radicals, you must do them completely separately. So you have to keep them separate from each other. So that becomes 3 times 3 times 7. 112, if you divide that, you may divide that by 4, is 4 times 28. So that's going to be 2 times 2 times 2 times 2 times 7. Again, these are square roots. When you take out the number from in the radical to outside, you multiply by the coefficient that's already there. So you're going to get 15 square roots of 7 plus 4 times 2, so 8 square roots of 7. That gives you 23 square roots of 7. For number 8, you're doing f of g of 2, so you got to plug in 2 into the g of x equation. So that's going to give you 2 plus 1, which is 3. And then you have to plug in 3 into the f of x equation, so that's going to give you 9 plus 6, which is 15. For number 9, you're going to plug in negative 3 into the f of x equation. That's going to give you 9 minus 6, which is 3. And then you're going to do g of 3, which is going to be 3 plus 1, which is 4. F of g of x is going to be f of x plus 1. So you're going to put in x plus 1 for all of the x's in the f of x equation. So you're going to do an x plus 1 squared for that x. And you're going to do 2 times x plus 1 for this x up here. So x plus 1 times x plus 1 is x squared plus 2x plus 1. And if you distribute this 2, you're going to get 2x plus 2. So if you add x squared plus 2x plus 1 plus 2x plus 2, you will get x squared plus 4x plus 3. For number 11, we're going to do this part first. So g of negative 3 is negative 3 plus 1, which is negative 2. Then we're going to do f of negative 2, which is going to be 4 minus 4, which is 0. And then we have to do g of 0, which is 0 plus 1, which is 1. For number 12, f of x plus g of x is just going to be 5x plus 3. Whoa, hold on, let me start this over. 5x. I'm not sure why it's erasing everything that I'm doing, so let me start over again. Excuse me. Five x plus 3 plus g of x, which is negative 2x plus 4, which is 3x plus 7. G of x minus f of x is going to be negative 2x plus 4 minus f of x, so minus 5x plus 3. You have to distribute the minus sign, so that gives you negative 7x plus 1. And for number 14, f of x times g of x is going to be 5x plus 3 times negative 2x plus 4. You can use the box method if you want. I'm just going to distribute negative 10x negative 10x squared plus 20x plus the negative 6x and plus 12. So negative 10x squared, this part right here gives you plus 14x plus 12. You can't reduce that because you don't have an equal sign or factor it because it's not really asking you to factor. So you just write that out. Negative 10x squared plus 14x plus 12. F of g of x is going to be f of negative 2x plus 4, which means that in the f of x equation, in place of the x, we're going to replace that with negative 2x plus 4. So it's going to be 5 times negative 2x plus 4 plus 3, which is negative 10x plus 20 plus 3, which is negative 10x plus 23. To finish off the practice test for chapter 4, let me go over starting with number 16. To do the inverse, first you change the f of x into a y. Then you switch the x and the y. So you will get x equals 1/2 y plus 2. And then you solve for y. So subtract 2. And then you're going to get rid of the 1/2. You're going to multiply both sides by 2. So that'll give you 2x minus 4 is equal to y. For the next one, you're going to have y is equal to 3x plus 6. You change the x and the y. Then you solve for y. So x minus 6 equals 3y. And divide both sides by 3. So you're going to get y is equal to x minus 6 over 3. If you rather have x minus 6 equals 3y and you want to divide each term by 3, that's also okay to do. And then your inverse function would look like that. For number 18, y is equal to negative 2/3 x plus 4. So x is equal to negative 2/3 y plus 4. So you're going to subtract 4. And then you're going to multiply both sides by negative 3/2. Go ahead and distribute. So you have negative 3/2 x plus 6 is equal to y. For number 19, you're going to have y is equal to x squared plus 5. Excuse me, x is equal to y squared plus 5. X minus 5 is equal to y squared, and then you're going to take the square root of both sides. So plus or minus x minus 5 is equal to y. For solving for x, you need to isolate the part of the equation that has an exponent. So we're going to isolate this part. So we're going to add the 4 first. Then we'll take the cube root of each side. So you get x minus 8 is equal to the cube root of 125, which is 5. And then you add 8. We didn't really square both sides, so you can... when you square both sides, that's really when you have to check your answer to check for extraneous roots. In this case, if you plug in a 13 here, 13 minus 8 is 5. 5 to the third is 125. Subtract 4 and you get 121. Here you have x to the 1/2, so you subtract 3. So you get x to the 1/2 is equal to 36. You're not taking the square root here. A lot of people would like to take the square root, but you're actually squaring because you have to undo this part. So you get x is equal to 36 to the second power, which is, let's see, 1296. And again, you can check your answers on that. It does work. For this one, you're going to subtract 7 from both sides first. So you're going to get x plus 3 to the 5/2 is equal to 32. Then you're going to raise each side to the 2/5 power. So you get x plus 3 is equal to, in this case, the 5th root of 32 squared, which is 2 squared, so that's 4. And then you subtract 3 from both sides, so x is equal to 1. And you can plug that back in. 1, that's 4. 4 to the 5/2 is the square root of 4, which is 2. 2 to the 5th is 32. 32 plus 7. In this case, you have to divide by 3 first before you can do the work. Then you can square both sides. So you get 2x plus 4 equals 16. Subtract 4, divide by 2. You get x is equal to 6. If you check your answer, then that would be 12 plus 4. So it's 3 times the square root of 16. So 3 times 4 is 12. For number 24, we're going to square each side. So you're going to get 3x is equal to x plus 6. Subtract x, 2x equals 6, x is equal to 3. Again, if you plug that back in, you'll see that 3 works as a solution. For the next problem, you're going to raise each side to the second power. So you get x squared is equal to 4x minus 3. You have to set the equation equal to 0. Don't forget to include your equal 0. A lot of you leave that out. Then you'll factor this, x minus 3, x minus 1. When you solve for x by setting them each equal to 0, x equals 3, x equals 1. If you check each answer, you get 3 equals the square root of 12 minus 3, 3 equals the square root of 9, 3 equals 3. That works. If you check 1, you get 1 is equal to square root of 4 minus 3, 1 is equal to the square root of 1, 1 equals 1. That works. So both answers work for number 25. For number 26, we're going to go ahead and square both sides on this one. You're going to get x squared plus 4x plus 4 is equal to 2x plus 7. Here, these cancel out. There you do need a trinomial, so be careful that you don't just put x squared plus 4. We're going to set this equation equal to 0. So you're going to get x squared plus 2x minus 3. That gives you x plus 3x minus 1. If you solve this, you get x equals negative 3, x equals 1. To check the answers in the original, if you're checking x equals negative 3, you would get negative 3 plus 2 equals the square root of negative 6 plus 7. So negative 1 equals the square root of 1. Negative 1 equals 1. No, that does not work. That's extraneous. If you try 1, you get 1 plus 2 equals the square root of 2 plus 7. So 3 equals the square root of 9. So 1 does work. For number 27, we're going to square both sides as it is. So this side, the square root and the square cancel. In this side, they do not. So you got to do, you're going to have 3 terms. The first one, you're going to square the 3. So that's 9. For the last term, we're going to square the square root of x plus 9. So you're just going to get x plus 9. In the middle term, you're going to multiply these two together and then double it. So you're going to get negative 3 square root of x plus 9 twice. So you're going to get negative 6 square root of x plus 9. So we're going to not set the equation equal to 0, but we need to isolate this portion. So we're going to move everything else to the other side. So I'm going to subtract 9. I'm going to subtract x, and I'm going to subtract this 9 as well from this side, excuse me. So make sure you're doing it once to each side of the equal sign. So the equal sign is here. These 9s cancel. The x's cancel. These 9s cancel. So on this side, we only have negative 6 square root of x plus 9. And on this side, the x's cancel. So I have 6 minus 18, which is negative 12. Because 6 goes in evenly into negative 12, I'm going to go ahead and divide it. If it didn't, I would just square both sides as it was. So I'm going to divide both sides by negative 6. So 2 is equal to the square root of x plus 9. Then you could square both sides. So 4 is equal to x plus 9. So x is equal to negative 5. You do want to check that in the original equation. So in the original equation, that would give me negative 5 plus 6 is equal to 3 minus negative 5 plus 9, the square root of 1, 3 minus the square root of 4. So 1 equals 3 minus 2. So that works. For number 28, you want to divide both sides by 3 first. So you get x to the 3/4 is equal to 192 divided by 3. So that's 64. And then you will raise each side to the 4/3 power. So you get the cube root of 64 to the 4th, which is 4 to the 4th, which is 256. For the graphing, you have an a value of negative 3. This is a square root function. Your HK is negative 5, 0. So 1, 1, 2, 3. 1, 2, 3, 4. The square root of 4 is 2. We have to go negative, sorry. The graph is negative, which means they're going underneath. It's a reflection. 1, 2, 3. The square root of 4, 1, 2, 3, 4 is 2. 2 times negative 3 is a negative 6. And then we're going to do the square root of 9. So 9 would be here. The square root of 9 is 3. And I have to multiply that by negative 3, which gives me negative 9. And then when you draw that, again, it's half of a parabola that's going sideways. For number 30, you have the a value of 4. The hk is negative 6, negative 4. So negative 6, negative 4. Make sure you draw those in. This is a cube root function, so it is going to go right and left. I'll give you a better graph when you take your actual test. The a value is 4, so at 1, you're going to go 1, 2, 3, 4 times the height, and then you got to go to 8. The cube root of 8 is 2. 1, 2, 3, 4, 5, 6, 7, 8, so 4 times as tall. And then you do the same thing on the other side, so 1, 1, 2, and then 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Because you don't have a graph, you can kind of just try to do it proportionately. And that's number 30.